All right. Good morning, guys. Let's jump right into this. Hey, not too bad at all on the test. There were some of you that had some issues sending it, but the ones that I have graded and got in the grade book, they don't look too bad at all. So, um, look pretty good. I think you guys are seeing this. So, uh, just to kind of get us going through here. Um, Are there any? Let's just do this. Just because you guys did actually really good on that take-home test, I'm not going to work through each problem. But if you have any questions over it, like if you want to see like how I work something, I'd be more than happy to kind of show it to you. But just let me know what you want to see. Just type something in the chat box. If you are good on the take-home test, I've already sent some of your mistakes to you. I think there was 5 of you that I already sent all your mistakes to. You other guys just kind of have to wait until I can grade it again since I didn't receive it at that time. And I know you guys had some technical issues, so I don't want you to think I'm trying to be a jerk or anything like that. But just make sure I'll get those to you. I'll try to do that tonight if I'm able to do that. Any questions though? Type it into the chat box. Like, hey, can I see you work this or that? Okay. So Alex, Ben said, what line did you want us to stop at for 1D? So if this is 1D right here, if this is 1D, in terms of where you want to stop, you would just need to get the width. You would just need to isolate W. Again, I just got your test, Ben, so I haven't really looked at it very closely or anything, so I couldn't really tell you whether you're good or not on that. But that's what I was looking for right here. Timmy, you saw your little mishap with the square root, right? Cool. All right. Ben, does that make sense? What I was looking for number one for 1D? Yes, no. Okay, cool. All right. So then Alex said 2C. So here is 2C. So Alex, it said how fast is Anne's grade changing at the 8th hour of study? So how is it changing at the 8th hour of study? So if you remember back a little bit, that's called the instantaneous rate of change. What is the rate of change at a particular moment? And that is just simply the derivative of what we have at that point, at 8. Oh, no, you're fine, Alex. All right. Any other questions? Morgan said she's good. Carter said he's good, just some simple mistakes. Timmy, you good? Ben, Alex, Ian, you all good? Just say, yeah, we're good. No, Morgan, that's forbidden. No, yeah, Morgan, we can. Let's just close this up right here, and then we'll kind of go from there. Yeah, look at 3B. I think everyone skipped 3B. Here's the first part. We know that we're looking for the area is equal to x times y. And basically, Ian, and I guess, Ian, you're the only one I'm talking to on this because everyone else, I think, skipped 3. The ones that I graded skipped 3. But what you had to do, I'm okay, Alex. I didn't grade yours. Didn't have it at 11:59 p.m. last night. That's on you, not me. So, but x, y, and you're restricted by this right here. You're restricted by this. So it's just this restriction, taking this restriction and solving it. This restriction and solving it for basically y. So multiply the whole thing by m times n. You get that, and you get y equals this. Plugging that back into y, and it takes you down all the way till you get the equations. All the way till you get the equations of x equals m over 2. And if you plug that back into the y here, you'll get n over 2. And then that represents your ratio of 1/2. Sorry about that. My dog, he sees squirrels and he goes crazy. And I will what I'll do is I'll scan this. I'll scan this and put it in our files just so everyone has it. What's 2EI? How many points less than the optimum gradable and score if she studies 1 hour less than the optimum? So here's our optimum is 4.72. One less would be 3.472. You type that into G, you'll get 56.517. Some of you actually showed like the point, like obviously the points difference in that, and that's fine as well. Oh, I see what you're saying, Timmy. Technically, it's saying how many points less than the optimum, less than the optimum gradable and score if she studies. So technically speaking, it's looking for the difference in this, that her actual grade and what it would be here. So whatever that difference is. If I mess that up on yours, Timmy, feel free to email me. Like if you had whatever that is, whatever that calculation is, then you can just feel free to shoot it to me, and I'd be more than happy to adjust your tests. So it should be 0.778 points less. That's really our answer. And then down here would be 0.496 points less. This would be the actual answer of what it was looking for. Does that make sense, Timmy? I'm looking at your test right now, Timmy, and you gave the actual grade for it. You got the grade right for the second one, but your first one was a little off. You got your grade right for this one, but it was a little off for that. Okay, cool. Next question or a problem like, hey, man, I want to see this, or how you did it. I got the answer, but, I feel like I got lucky. Anybody? Okay, if you're good, let me just type in the chat box, I'm good, or thumbs up, smiley face, whatever, so we can move on. Okay, cool. I'm going to mute my mic real quick. All right, sorry about that. So Morgan said, can we discuss the AP test? So by all means, questions or what you particularly want to talk about, Morgan. I will be furious, Tim. Have you guys heard anything from the school, like administration, yet about anything? Okay, so Morgan says no, nothing. Okay, cool. All right, so I am just speaking in terms of if I am a student in my class. I'm not speaking in as a representation for the school. I'm just speaking directly as I'm a senior in high school here. To go back to August and to look at that number one classwork and to think about literally how far we've come is absolutely insane. We have literally put in work in this class, some serious work, some challenging work. Some of you haven't been this challenged in a math class in a very long time. So to me, what I see is I see a group of students who have literally poured into calculus and understanding calculus in a better way. So I'm not going to give you, I'm not going to tell you what to do, but if it's me and I'm sitting there and I'm thinking, man, I've poured into this, what it is, how do you go from a 3 hour and 15-minute test to a 45-minute test? Hey, who knows? Who knows what this, who knows what it looks like? That's the talk among AP teachers right now, is like, you can't wrap your head around literally changing from a 3 hour and 15-minute calculus test, 2 sections, to a 45-minute. So to me, I don't know. I just see you all pouring. You guys have poured so much into this. It's crazy. But It has always been the policy of Grove City Christian High School, to my knowledge, that you take the test. You don't have the option. So I don't know. I don't know what that looks like. That's my thoughts, Tim. Is like, hey, are they going to remove like the nice, beautiful, like, are they going to remove? I don't want to call them the fluff, but the easier questions, and just shoot out problems like number 3, literally on this test, like where you literally have to crank your mind to get it. And I don't know how long this test right here, these 4 problems took some of you. But some of these problems, I mean, it took me well over 45 minutes, to work all of it. So, and Morgan, obviously, we have the internet, so we're full of resources. So I don't want to misspeak against the College Board, but to my knowledge, everything's looking like you still get your credit for it. However, this is what I will tell you guys that I told even someone like Davey last year. Hey, Davey, if you even score a 5 on this, and you guys have, when I say you all have a 10 times more upper hand than Davey, and even though Davey's probably one of the most intelligent students I've ever met, you all even have an upper hand on him because he didn't go into the depth that we went this year. So I even told Davey, if you even score a 5 on this, hey, just take your, if you feel like you can skip calculus in college and, you get it, whatever, you can. But I would still encourage to take calculus in college. While this is a strong foundation of a class, and you're going to go in there and you're like, man, because I think it was Tim that said his brother was in calculus at Ohio State, and he said that they were doing kind of the same stuff. So you're going to see the same stuff again. Maybe that just builds a stronger foundation. You're going to learn more, maybe more shortcuts, more ways to do stuff. But to me, I would look at it as kind of like this laid a strong foundation for your calculus. So going into college, you're going to have a strong upper hand. Hey, take the test. If you pass it, you pass it. Cool. That's awesome. You can brag about that you were a part of the coronavirus AP calculus test that was only 45 minutes and was, 1 question. So I don't know. It's kind of, there's a lot of factors involved. But again, to answer your question, Morgan, I would go to the College Board, and we're waiting. And we should be there's an announcement coming out. Let me look real quick. And some of you may know this. I don't know. But there is an announcement coming out on April. On April 3rd. And on April 3rd, they're going to release additional information about the test. So April 3rd, we will kind of know a little bit more information. But on that, we can maybe we'll kind of have a little bit of understanding of what the test kind of looks like. So then I think you evaluate them. I don't want you guys to stress over it. However, we're going to continue in instruction as though we're taking a 3-hour and 15-minute test. And I just think that's best. We've kind of kept a strong pace all year long. So I think it's vital that we continue on. Tim said, how do you best prepare for an online math test? Honestly, people ask me, how do you prepare for even a paper math test? I don't think it's possible. I don't think you go and study for hours upon hours. You either know it or you don't. And it's just going to come from practice. I think you can review all the stuff we've gone through to kind of get some more hits, but the only way to study is to actual practice the work. You just can't look at it. Some people can. I'm not someone who can just look at it and photographic memory it, but I would have to work additional practice problems. But I will tell you this, that I will give you a binder of 4 AP calculus tests with answers, with solutions, and we will work through those. So I am going to do my best to prepare you for it, regardless of what it looks like. So, and again, that sounds a little bit crazy, but once on April 3rd, once we get a little bit additional information, then we can kind of make a conclusion from there. But I would encourage all of you to stay positive. Not that big of a deal. And I don't. You guys are faced with a lot of pressures right now. I don't want one of them to be the AP exam. I mean, you guys are having to face the reality of the best months of your senior year. So I want to. If I can do anything, I'd want to take that pressure off of you guys and say, hey, that's small fries to the grand scheme of things here, to what you guys are really dealing with and have to go through. So. All right. Yeah, we will. If something doesn't happen, if for some reason something crazy happens and we don't get to see each other again, we will connect one last time for sure before you guys go to college. And I still owe Tim and Carter. I still owe you guys some steak and shake. So I haven't forgotten. All right. Any other questions about AP exam or the take-home test? Okay. So I'm going to have you guys get out number 24 classwork. Once you get that out, I'm adjusting the camera here. Once you get that out, will you please give me a thumbs up or something in the chat box? Thumbs up. Cool. Carter, Tim, Morgan, Ian. Good. Not sure if Ben, you still with us? Cool. All right, guys. So looking at number 24, indeterminate forms and L hospitals rule. All right. So we return now to where we begin our study of calculus, limits. We analyze problems like the limit as x approaches 2 of x minus 2 over x squared minus 4, and the limit as x approaches infinity, 1 minus 4x minus 5x squared over 3x squared minus x minus 4. In the first limit, if we plugged in x equals 2, we would get 0 over 0. And in the second limit, plugging in infinity gives negative infinity over infinity. Both of these are called indeterminate forms. Highlighter. In both cases, there are rules that are followed that seem to give different results. In the first problem, where you get 0 over 0, you have always been told that a fraction with the numerator of 0 is 0. However, you have also been told a fraction with the denominator of 0 does not exist. So is the limit 0, does not exist, or is it some other number? In the second problem, we get negative infinity over infinity. You've been told that a fraction with a numerator that goes to infinity is infinity. However, you've also been told that a fraction with a denominator that goes to infinity is 0. So is the limit infinity or 0? Or maybe the infinities cancel out and the answer is -1. Add to the issue that infinity is not a number and we can't treat it like a number. That's why these expressions are called indeterminate forms, as it is not clear what is happening in the limit. There are 5 additional indeterminate forms. 0 plus or minus infinity, and you can kind of see the conflict with this. Infinity minus infinity. Well, x minus x is 0, but infinity is not a number. 1 to infinity. Well, 1 to the power of x is equal to 1, but x to infinity is infinity. So a conflict there. 0 to the 0 power. Well, 0 to the x power is 0, and x to the 0 power is 1. Infinity to the 0 power, and then infinity to the x is infinity, x to the 0 is 1. So these are all just simply more of the indeterminate forms. So these are just indeterminate. So now some of you may be saying, well, oh man, I don't remember talking about infinity over negative infinity. If you go to page 23, I had to look this up. Page 23 of your manual of this. So we're on 149 now. But if you go back to page 23, you'll see some, you will see all this, all just our introduction to limits. Okay. It'll explain this because I know this has been a while since we've done that. All right. So note that the study of indeterminate forms is new to AP Calculus exam in 2017. Having previously been on the BC exam, it is not clear what depth the indeterminate forms will be covered on the AP exam. For now, this manual will cover the indeterminate forms of 0 over 0 and infinity over infinity. And the non-essential sections, as well as the BC manual, will handle the more complicated additional forms. We have already studied methods of finding limits in the forms of 0 over 0 and infinity over infinity. So, looking at this first problem. So, you all can recall that we would work a problem like this. And if you go back to page like 23 up here, if you went back to page 23, you would see these steps that we're about to do. Your first step, and what you're trying to do is say, what is y doing as x is approaching infinity for this function? That's what a limit is. What is y doing as x approaches infinity for this function? Well, on a graph, we can see that, but algebraically, our first step is to plug it in. If you plug a 2 in here, 2 squared is 4, 4 minus 4 is 0. So plugging it in won't work. So after plug it in, what was the second step? Someone type that into the chat box. What was our second step after we plugged it in? Does anybody remember that? Very good. Step 2 is to factor. Step number 2 is to factor. So can't factor the numerator, but I can factor the denominator. It is a difference of squares, guys. So that would just be x minus 2, x plus 2. Then from there, we factor and cancel. And I get the limit as x approaches 2 as 1 over x plus 2. Then our steps start all over, guys. Then we go back to step 1. Step 1 is to plug it in. So we plug it in there. we get 1 over 2 plus 2, and we find it to be 1/4. So y is approaching 1/4 as x approaches 2. All right, let's go to this next one. So the limit as x approaches infinity of this function right here is equal to. Now, I don't know if any of you have like your binder near, and you can go look at 23 or page 23 and see exactly like where we're pulling this from. But when a limit was equal to infinity, okay, when the limit was approaching infinity, what we would want to do here, okay, is ask ourselves if we took if we put all of these under a denominator, what would our answer, or would it cancel basically everything out? Okay, so if I put 1, and you'd have to look at your greatest power, and it's x squared. So if I put all the numerator under x squared, would it cancel out to where I just have constants in the numerator? And the answer to that would be yes. And it kind of goes back up to anytime you have infinity in the denominator, that goes back up here. If you ever have a fraction with the denominator that goes to infinity, your answer is 0. Okay, so watch this. And again, this has been a little bit since we've done this. So it looks something like this. 1 over x squared minus 4x over x squared minus 5x squared over x squared. And all of that is over 3x squared over x squared minus x over x squared minus 4 over x squared. From here, we cancel what we can. So we cancel an x and one of those x's. We cancel both of those. We cancel both of those. We cancel this one, and that'll stay there. So then that will lead me to this. 1 over x squared minus 4 over x minus 5 all over 3 minus 1 over x minus 4 over x squared. And if I plug infinity into all of this, into each denominator, okay, now notice all these are constants. So what that'll allow me to do, if I put infinity in all this, anytime you have infinity in the denominator, again, that's what this is like, we're just reviewing from past times. So 1 over infinity would be 0, or 1 over infinity squared. 4 over, or minus 4 over infinity would be 0. And then just minus 5. All over 3 minus 1 over infinity is 0. Negative 4 over infinity squared would be minus 0. So then that takes me to negative 5 over 3. Okay. So, looking though, I could have known that the answer to this is -5/3 actually from the beginning of the problem, though. And that just goes back to, if you think about what's happening, is it bottom heavy, top heavy the same? And the power of this in the numerator and the denominator is the same. So it's just a ratio of the coefficients of that power. So -5/3. And that's another way we could look at that problem. Obviously, this is another way as well. Okay. However, these techniques won't work with limit as x approaches 0 right here. And it won't work with this one as limit approaches infinity. The first is in the form, if you plug in 0, you're going to get 0/0. But no factoring is possible. So you can't do it. The second one is in the form of infinity over infinity. But dividing every term by x cubed won't work with the e to the x power. So then you won't have a constant in the numerator. You would have e to the x, so that wouldn't work either. So we flip our paper to the back, and we learn the new way. L'Hospital's rule. And it's named after the 17th century French mathematician Guillaume de L'Hospital. Allows us to evaluate limits involving indeterminate forms, and alternating spelling is L'Hospital. Okay. Suppose we have one of the two following cases. The limit as x approaches a, and it gives us 0/0, or as the limit as approaches a gives us some form of infinity over infinity, where a can be any real number, infinity or negative infinity. Then what we would say is the limit of this is equal to the limit of the derivative of the function. Now, this does not change the way you do limits. So I'm not giving you something that, hey, Mr. Oppot gave us, now he's giving us this method that will work in solving limits. While it will be very helpful, okay, but it's really just for those with indeterminate forms. So like, for instance, look at number 1. If I was able, I have to follow those same steps that we talked about in the very beginning. And that's step 1, plug it in. Step 2, factor and cancel. And then step 3, that's where we would do where we would go from the left and the right limits, which is going towards infinity or negative infinity or does not exist. But then the fourth one was indeterminate. And on those notes, we would literally, or on our homework, if something was indeterminate, we would write indeterminate. However, this will help clean that up. Okay? So you still follow your methods of evaluating limits, plug it in, factor, cancel, approach on the left, approach on the right. But if you're having an issue, you can obviously just use the L'Hospital's rule now. So let's jump into this. So if I plug in the limit of x going to 2 for this, I'm going to get 3 times 2 squared minus 7 times 2 plus 2 all over 2 minus 2. That's going to give me 12 minus 14, which is -2. -2 plus 2 is 0. So that gives me 0/0. So what L. Hospital's rule says is this. If you get this, you don't have to write out indeterminate. You can just take the derivative of the function. Okay? Just take the derivative of the function. Now, don't freak out thinking, oh, we got to go low D high, high D low. We can just take the derivative of the numerator and of the denominator. So, looking at this, the limit as x approaches 2, now we change it to this. 6x minus 7 over 1. Now we plug 2 in. 6 times 2 minus 7 over 1. We get 12 minus 7 over 1, and that would give me 5. So this limit, if we were to go type this into y equals, and we were to say, what is the y doing as x goes to 2? The y is approaching 5. Does that make a little bit of sense? Yes, no? Yep. All right. Cool. Let's jump over to number 2. So number 2, plug it in. The limit as x approaches, that's negative 3, looks like this. Negative 3 plus 3 over the square root of negative 3 squared minus 5 minus 2. Okay? So right here, negative 3 plus 3 is 0. That would be 9 minus 5 is 4. The square root of 4 is 2. 2 minus 2 is 0. So when we get a 0 over 0 with a limit after plugging it in, we can't factor anything. Then we just need to take the derivative. So let's go ahead and take the derivative. So the limit as x approaches negative 3 is equal to the same thing, but just the derivative. So the derivative of, let's go ahead and look. Obviously, the derivative of the top is 1. So we could say 1 over, and then let's bring this up here and make x squared minus 5 to the 1/2 power minus 2. And we can go ahead and scratch out minus 2 just because we know it's a constant, so it's going to be 0. So that's going to be 1/2 x squared minus 5 times 2x. And that's going to be to the negative 1/2. Sorry about that. So my 2's basically will look like this. 2x over, push that down, to radical x squared minus 5. Then we know my 2's cancel. So I have x, 1 over x over radical x squared minus 5. Now, again, if we flip that up, that will take us, if we divide, keep, flip, change, that will take us to radical x squared minus 5 over x. Now plug that negative 3 in, and we get radical 4 over negative 3, which is equal to negative 2/3. Thumbs up. We good on that? So Ian asked a good question. Why don't we do low D high? Is this just circumstantial for indeterminate forms? No, these would be functions here that we could kind of work out. And if you did do low D high, that would take you to the same answer. No, hey, Ian, I just misspoke. Sorry. Because if you did low D high on this, think at the bottom you'd have x minus 2, x minus 2. So that would not allow you to plug in 2 into x. But the reason we can just take the derivative of the numerator and the denominator, sorry about that, would be because it's the circumstance for this right here. It is L Hospital's rule that you can just derive the numerator and derive the denominator based on that right there. Does that make sense, Ian? Sorry about that confusion. Okay, so yeah, Ian asked a good question, Mark, because technically here we'd have to do, this is quotient rule, but again, L Hospital's rule said just derive the numerator, the denominator, and then plug it in, and you will get your answer. All right, let's jump down to number 3. Okay, so number 3, again, same thing. Yeah, always, Tim, always got the mint. So our first step is plugging this in, all right? So when I plug 2 in here, if I 2 cubed plus 2 squared minus 8 times 2 minus 12, that's obviously going to give me 0. And if I plug 2 into 2 cubed plus 8 times 2 squared plus 20 times 2 plus 16, that's obviously going to give me 0. Okay? So pretty obvious there that we get 0. No, I'm just joking. That's not obvious at all. But after already knowing this, I know this first one's going to give us 0 over 0. Okay? You can just trust me on that. If you plugged it in, you're going to get 0 over 0. On your homework, you're going to need to plug it in. But for the sake of this video and time, just know that it's 0 over 0. On your homework, plug it in to make sure it's 0 over 0. Because if it's not, then you could work with it from there. Okay, so then that takes me to the derivative of it. The derivative of the numerator and denominator as negative 2. So that would be 3x squared plus 2x minus 8 over 3x squared plus 16x plus 20. Now, if you were to plug negative 2 into that, this one may be a little bit easier to do. That would be 12 minus 4, which is 8. 8 minus 8 is 0. That would be 12. Sorry. that would be 12 minus 32 plus 20, which is also 0. So after my first derivative, I found 0 is 0. So tell me this. What do you think we should do from there? Call it indeterminate, or any other ideas of what we could do from there? Yeah, so good answers there. And what we're actually going to do is take the second derivative of the top and the bottom. So just like this. So we could really say that L'Hospital's rule extends to f prime of x over g prime of x is also equal to f prime prime of x and g prime prime of x. So going back here to number 3. The limit as x approaches -2 from 6x plus 2 over 6x plus 16. So if I plug a -2 in there, that's -12 plus 2, which is -10. Plug in a -2 there, that's 12 plus 16, which is 4. So that is equal to -5/2. Okay. Moving right along to 4. So 4, if you plug that in, 1 minus 2 plus 1 would be 0. Some of that you can do mental. Some you may have to plug in, do a little bit of work. Plug in here, 1 minus 3 would be -2, plus 3 would take me back to 1, and then -1 would take me back to 0. So then the limit of x approaches 1. Let's derive it. 3x squared minus 4x plus 1 over 3x squared minus 6x plus 3. And again, some of you actually said, I think Ian said factor here. And that wasn't a bad idea on that second one. Hey, let's factor, see if we can get something to cancel. But keep in mind, your first step is always to plug it in and see what you get. If you get that 0, 0, then you know to take the second derivative. Plug it in here. That would be 3 minus 4, which is -1. -1 plus 1 is 0, over 3 minus 6 is -3. -3 plus 3 is 0. So then my limit as x approaches 1 would be 6x minus 4 over 6x minus 6. That would give me 2 over 0. And that would mean that this limit does not exist. This limit does not exist because 0 is in the denominator. All right, let's jump down here to 5. Okay, so 5. So if we take the limit of this, if we plug in a 0 there, what's cosine of 0? Cosine of 0 is what? Yeah. 1 minus 1 over, obviously 0 minus 0 would take us to 0 over 0. Okay? So then that means let's take the derivative. The limit as x goes to 0 is equal to the derivative of cosine is negative sine x. The derivative of 1 is a constant, so that's 0 over 2x minus 1. Okay? So then from there, plug it in. Negative sine x of 0 would be what? Should just be 0 over, and if we plug 0 in there, we get negative 1. So then therefore, when 0 is on top, we say it is 0. All right, looking at number 6. So the limit as x approaches 1 is equal to ln of 1 would be 0, just algebra there, minus 1 plus 1, all over e to the first power is just e, minus e times 1 is just e, and that would take me to 0 over 0. So then we 0 over 0, we take the derivative. The limit of as x is going to 1 would be ln of x is 1 over x minus 1 over e to the x. E to the x, and it's actually minus e. Minus e. Again, if I plug that 1 in, I'm going to get 0 is 0. So then I take the derivative again. The limit as x is going to 1. The derivative of 1 over x would be negative 1 over x squared over, and now e is just like, it's very similar to pi, so that would just simply be e to the x. The derivative of e to the x is e to the x. Then if I plug in the 1, I'm going to have an e in the denominator and a negative 1 in the numerator. So negative 1 over e. And that would be my answer. Give me a thumbs up if you're still with me, still hanging on. Okay. So now let's go to number 7. What's the limit of the function as x goes to 0? So you punch in this first one. You should see really quick that if you plug in the first time, you're going to get 0 over 0. 2 sine of 0 is 0, minus sine of 2 times 0 is 0. So that's 0. Sine of 0 is 0, minus 0 times cosine of 0 would be 0 as well. So should be pretty obvious that we're getting 0, 0 in the first one. So then we derive it. So the limit as x goes to 0. So think about taking that 2 out, or like the 2 away, and just saying 2, and then the derivative of sine would be cosine. So 2 cosine x, and then minus. Now I'm doing a lot of mental math right here. If you need to go to get a separate sheet of paper and do that, that'd be completely fine. But sine of 2x. So if you remember here, we're going to say it is cosine of 2. The angle stays the same, so the derivative of sine is cosine of 2x, but then we have to multiply times the derivative of 2x, which is 2. So that should come out to be minus 2 cosine of 2x. All over and hey, let me just kind of show you right here. I just want to make sure we're good on this. So sine of 2x, the derivative of sine is cosine. Keep the angle the same. Then you multiply times the derivative of the inside. So then that's where I come up with that 2 cosine of 2x. Just making sure we're good with that. Okay, and then the subtraction sign was there. So then the next one, the bottom there, that derivative of sine x is cosine x. And then here we're dealing with this is product rule, right? So that's cosine x, and then x times cosine x would be x. So and it's going to be a plus. So plus x, the derivative of cosine is sine x, and then we say plus, and I know it's actually going to be a minus here, but I say because product rule is plus the first. So we did the derivative. All right. So here we did the first one times the derivative of the second one. Now we do the second one times the derivative of the first. So that would be minus cosine x. Okay. So now from there, if we plug 0 in here, we should see here that if we plug 0 into all this, it's still going to give us, because we know that sine of 0, or because we know here that cosine of 0 and that cosine of 0 times those two is going to give us 0. Same thing on the bottom. Cosine of 0 is 0. 0 times sine x minus cosine x, 0. All of that is going to give us 0 over 0 again. Okay, so then we derive again. So the limit of x going to 0. So take that 2 kind of to the side. So 2, and then the derivative of cosine would be actually negative sine x. So let's say negative 2 sine x. And then right over here, this is product rule. So take the first times the derivative of the other one, the derivative of cosine of 2x would be sine of 2x times 2. So that outside 2 times that inside 2 would take me to plus 4 cosine x. Or I say cosine, I meant sine of 2x. And again, I'm doing a lot of mental stuff right here. Don't really have room to kind of work all this out. And obviously, the reason it goes to plus is because cosine is negative sine. All over here, the derivative, and we're saying cosine of x if we're looking at cosine x plus x sine of x minus cosine x, oh, okay, yeah. I was about to say that looks a little bit weird. If you think about this cosine x here and that cosine x will cancel. Because cosine x minus cosine x cancels. So then we just have to get x times sine x. So x, the first, times the derivative of the second, which is cosine x, plus sine x times the derivative of x, which is 1. And then here, again, if you plug 0 into all this, again, and I'm, obviously you can use unit circle here, but if you, on your homework, I mean, I'm cool if you want to punch that into a calculator. If you punch it onto a calculator, you're going to see again that you get 0 over 0. So yet we have to derive a third time. The limit as x goes to 0 is equal to, or not really equal to, but of the function. So the derivative of negative 2 sine x is negative 2 cosine x. Plus, again, if you just take that 4 to the side and then sine of 2x, that should take you to 8 cosine of 2x. And that's kind of, if you all remember, like doing like the derivative to like the 50th power or whatever, that we're kind of doing that same kind of trend here. And that's all over. We have to derive this. So we say x times the derivative of cosine, which actually be negative sine x. And then plus cosine x times 1 is just cosine x, and the derivative of sine x would just simply be cosine x. Give you a second to get that down. Just make sure you got it. Okay. So the key part here is that we know that cosine of 0 is 1. All right. So cosine of 0 is 1 here. And what stopped is obviously up here of cosine being, obviously it's being 1, but 2 minus 2 is 0. But here it kind of presents something else. Here sine x is 0. So sine of 0 is 0. So that was the issue in there. But here it presents something different because now we have a -2 and an 8. So how do I know that, this is probably the one up here? Again, 2 minus 2 was our thing there. But here it would be a little bit different. So you could type it all into a calculator and see what we get from all this. We know that this is going to give us -2 plus 8 cosine of 2. Let me calculate this real quick. I have the answer, but I typed it all in my calculator. So that would equal 8. Sorry about that. Over that would be 0 plus 1 plus 1. -2 plus 8 is 6. 6 over 2 is 3. A lot of work there, a lot of derivatives. Be patient, be careful with all this because obviously I went through it kind of fast with a little bit of mental math going through there. But again, take your time. And when you see some clearing, just know that cosine of 0 is 1, sine of 0 is 0. So just know that. And then you're just looking for when you can plug it in and it'll work. And I'm fine with using a calculator on a problem like this. So, all right. And if you got to your 45-minute AP exam and you saw that you couldn't use a calculator on something like this, you just use your unit circle and just take your time working it out, if time is even really a thing anymore. Okay. So last two, and then we're done. So looking at number 8. So now we're approaching infinity. Okay. So as x approaches infinity, so if we punch in a really big number here and a really big number here, we are going to find that that's going to lead us to a negative infinity. And again, this is when I think some of you guys made fun of me because I put like the number 100 in here just to kind of see where it would take me. So as x goes to infinity, that would take me to negative infinity over infinity. And when that's the case, El Hospital's rule comes into effect. So we just take the derivative of that. So the limit as x approaches infinity would be equal to, take the derivative of that, and that'd be negative 10x minus 4 over 6x minus 1. Okay, and as we see here, again, since infinity is not a number, we can just type in a large number, and we're going to see that that's going to continue to take us. This is going to be negative infinity up here at the top. And that, if I plug in like 100 there, 6 times 100 is 600. So that's going to be headed towards infinity as well. So then we say our limit as x approaches infinity would be negative 10 over 6, which would actually be negative 5 over 3. And that would actually be my answer. We cool on under. I'm not typing. I'm not really showing you that, but are you guys all with me in saying, hey, if you punch in a big number here, it's going to this. It's not going to take us to an actual number. It's just going to keep taking us to infinity over infinity. Yeah, you could. Absolutely, Morgan. You could just put them all over that. And I think, is this the one we did solve on the front? I think that is the way we did. But your issue is going to run into over here, like with number 9. You wouldn't be able to solve it on the front. And you're basically, again, you're just plugging numbers in to this, and you're seeing where that number takes you. If it takes you, it's going to probably take you to a bigger number. So you're just deriving it until you find something of what it's taking you to. All right, last one. So again, if I punch in like 100 here, that should be pretty obvious. 4 times 100 squared is going to be a very large number minus a smaller number plus a small number. That's going to lead me to infinity over e to the 5. And again, if I type in 100 there, that would give me a very, very large number. And same thing with ln of x of 100. That would give me like 4.6 something. So again, that would be leading me to higher numbers as well. Okay. Going back to deriving it, the limit as x approaches infinity would be 8x minus 5 over 5 e to the 5x. Remember, take the multiply this times the derivative of the exponent, and then plus the derivative of ln of x is 1 over x. If I type in 100 there, that's going to give me 795. If I type in 200, it's going to keep going up and up and up. So that's going to give me infinity there. If I type in 100 there, times that 5, and even though that's a fraction right here, that's still taking me to infinity. So then take the derivative again. We find it to be 8 over, that would be 25. 5 times 5 is 25 e to the 5x, and then minus 1 over x squared. The derivative of 1 over x is minus 1 over x squared. So I have nothing to type into the numerator. I have everything to type into the denominator. So if I was to type in, just kind of an example here. If I was to type in 8 over 25e raised to the 5 times 100 minus 1 over 100 squared, what does that take me to? Okay, 100 is too big of a number. Sorry. Yeah, I guess it would be. So let me try another one. Let me try. Let's just try even just something like 1. That would be going towards infinity. Just trying 1. and that's 0.00. So if I tried 2, see where 2 takes you. 1.45 e to the -5. So that's even more closer to 0, guys. So what I'm approaching here would simply be 0. All right, so that's infinities, approaching infinity. Again, you're just punching in numbers, seeing, hey, what is this doing? If I type in a large number here, oh, it'd still be approaching this. Derive, 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 same thing here. I think this was all pretty straightforward. Over here, it gets a little dicey. Just be careful over here, like with number 7. Just be really, really careful about taking those derivatives, because obviously some of them you're taking product rule, some you got to cancel. So just kind of keep that in mind within it all. So questions of me on number 24 notes. Questions of me on number 24 notes. I see no questions. Can I get a thumbs up? We're good. Hey, all right, I'm okay with this. Carter's good. Ben's good. I'm happy to help. Don't be afraid to say, hey, I didn't understand this or that. I'm more than happy to help you guys. Good. Timmy's good. Morgan says she's good. Median's good. Alex is good. Of course, Alex is good. All right. Hey, guys, make sure you pay special attention to that change in schedule. We're not meeting tomorrow because we did that today. After thinking about it, I was like, man, there's no reason to meet 3 times. So, again, complete number 24 homework tomorrow. And then on Thursday, we will do 25 homework review and 25 notes. Okay? So, it shouldn't be too bad in here in an hour and a half today. So, that's not too bad at all. If you don't have any questions of me, feel free to be dismissed from this session. Thanks so much for being here today, guys. I really appreciate it. If you have any questions, just feel free to type them in the chat box. Hey, not a problem, Morgan. Have a good day. Hey, you too, Alex. See ya.